This video is going to be on the wingnut effect, intermediate axis tennis racket effect, or Dzhanibekov effect. Veritasium YouTube channel video did it better. But this has been around for 100 years or more, and it is an interesting effect. And learning how it really works is useful. So let's do that. I'm going to use my head as an example of the object we're going to be dealing with. And an egg. It's similar to an egg. And also a teardrop, and the shape of the Earth not being completely spherical, and it being a liquid-filled item in the case of the Earth, the egg, and apparently my head. So here we go. We'll be using the tennis racket, then the wingnut. Let's say we start with a sphere, though. A spherical object has, we're going to create a hypothetical perfect spherical object. Now, to within plus or minus a foot, if you made a planet-sized sphere, you could technically make it so consistent that it would have literally no deviation from where the center of gravity is for this object, or the inertial center. So you could end up with, literally, a perfect sphere. This has been done, that's great. But if it's even one molecule off, there will be a major axis and minor axis dimension, at least, in some direction somewhere. It'll be longer than the rest of them. And we'll call that the north and south point, just because we're going to do the Earth example too. And again, just like that, can't actually be a perfect sphere. One end of that or another is going to be just slightly further from the center of gravity or whatever by a couple of molecules. Let's just imagine that. So it'll be a little top heavy or bottom heavy and rotating on this axis. We're going to put it as a rotational axis. The major axis is the longest dimension. We're just going to use that as our example. Now, on this channel, you may have noticed my channel has a lot of videos concerning and alludes to ballistics, bullets, etc. A spherical round ball fired out of a black powder weapon. It's an example. And the mechanically and aerodynamically seemingly perfect shape of a teardrop. And what we actually end up using for bullets, spacecraft, and re-entry vehicles. So, let's talk about this. The tennis racket analogy is what is used mostly, and the Veritasium video does a very good job of it. If you take a tennis racket, here's the bulbous end, here's the handle, and if you rotate it around the handle, that's reasonably stabilized. Most of the mass is at one end, but it will spin stabilize and keep it from wobbling too much. But it will still wobble. It will have a precession, and it will do it in a particular timing pattern. If you could somehow maintain its rotation, it will form a slightly off-axis wobble, just like the Earth does over thousands of years. Because we can observe this, because you can calculate it or estimate it or whatever, you can figure out what its timing is. Yes, that has something to do with it. Now, the Earth is more bottom heavy than top heavy. South Pole has slightly more matter and mass to it, and it's more broad at the bottom. Hips don't lie. So, it's rotating on its axis, so all of the weight along the entire spinning surface is almost evenly distributed. And, just like a top or a gyroscope, more of the mass is pulled out at the equator, but slightly more of it is at the bottom than at the top, by a couple of miles or something like that. Now, what that means in the long run is that the Earth is not completely symmetrical in any of these dimensions except the one it's currently rotating on. The mass distribution of its rotation on its axis throws the mass evenly around it, or making its own self orbit its center on axis with North and South Pole. Now, because of that, this means that it's not going to be able to tip end over end so that the North Pole, physical North Pole of the Earth, points to the south end of the sky. It's simply that thing that's happening. Now, at one point, the Russians found out from this, I can't pronounce his name, scientist's effect, from him literally unscrewing a wingnut and watching it spin, and then randomly, well, not randomly, at specific timing, flip end over, keep rotating, and keep doing this. Because the wingnut edges are pointed up this way, it put a large weight here, less weight at the ends, and was rotating this way. It could also have rotated end over and then spun. Both dimensions. Both dimensions. So, how does this work? Well, if you're rotating it in such a way that it's not completely balanced, there's a slight, in that case of a wingnut, it wanting to tilt this way to try to make it work. If you throw it from the wings this way, end over with it giving you the profile of the screw threads, and then going over and then doing it again for the top end, it's going to eventually flip this way. You would expect it. If you took a wingnut, if you don't know what they look like, and threw it like a throwing star, it would do this. But you'd also say to yourself, it's eventually going to flip, right? Because it's not completely stabilized. Now we go back to the bullet analogy. Bullets are usually, not always, have one end that has more weight than the other, front to back, and they're spin stabilized on the only axis, the cylinder axis, that they're completely symmetrical at. Now, here's where it gets funny. There are bullets that were invented that were asymmetrical. They do exist. They were fired through, a bore that was egg-shaped, or not egg-shaped, but oval-shaped. And then the oval-shaped bore twisted, so it would spin stabilize it and fly theoretically like throwing a pebble that was flattened, or some other crazy stuff. The idea was to create a slug that would come out of a gun that would be pressed into it by the explosion, and then we would twist. Now, you can look these up, and they do exist. And they're an odd form of squeeze bore because they presented the same amount of surface area behind and spun the bullet slightly. What good is this? Well, all it did was take a long hunk of metal, flatten it out in one dimension, and then spin it. And it didn't work any better because the idea was to try to avoid having grooves, lands and grooves, for making rifling, and trying to do that instead of doing rifling because at one time rifling presented a problem of letting gases escape and lowering the speed on the bullet. Smooth bores would fire a metal stick-shaped bullet in a way that would make it go pretty fast. This would slightly lower the speed, but it would spin stabilize it. That's what rifling's done for. But this also meant that people came up with weird ways trying to get around that because they saw it as a problem. Also to create patents and inventions that would be novel and interesting and maybe make a bullet that didn't have rifling on it, I guess. But anyway, I'm going off on a tangent, mostly because I have distractions here. Let's get back to the tennis racket and the wingnut and the earth. So what causes this effect? Okay, we're at the 8-minute mark, so I'll get to the point. Any non-completely symmetrical weight distribution in an object will cause it to spin unstable. If you make a bullet, and it's coming straight at you, and it's rotating this way, but at the base of the bullet you put a little more weight here than on the other side because it's not quite a completely consistent jacketing, or maybe it has a, let's say, a highly dense piece of metal in the middle, like a pin, tungsten comes to mind. If it's not completely symmetrical, it will have more mass, let's say, on the butt end, and it'll be spinning that mass, which means the back end of the bullet will start doing this. The front might be completely centered, but the back end will do this, and it will do this as it goes through the air. Now, how is this useful for reentry vehicles? I'm glad you asked. To try to make a steerable reentry vehicle, basically an object falling into the atmosphere and you're trying to get it to skip off the atmosphere exactly right, the idea was to make it to where it did not require a guidance system. So the first reentry vehicles that were tested, Mercury, landing on the moon thing, and just space exploration in general, they decided to make something a little bit weird. They found an odd shape that would work, and you can make it completely symmetrical, and it's the spaceship shape. I'll put a link to the Gemini or whatever reentry vehicle Tal Fledermaus video. But what they did is, in order to make it to where they could kind of make it steer, they found out something funny. First of all, it would start rotating on its axis if you didn't give it some weight distribution issue. So they put more weight on one part. Okay. And that would either make that part go up or down, so they had to test that first. Next thing they figured out is if they moved the center of gravity, they could also take advantage of it having a physically asymmetrical shape, so it would actually start, well, not flying, but divert one way or another, including making it go into a shallower or more extreme angle if they needed to, making it semi-steerable and semi-controllable in re-entry, a controlled crash into the atmosphere. This was a very good idea to be able to do this because you're at the mercy of gravity, aerodynamics, and whether or not everybody got the rivets in properly. And the heat shield has some limitations on it. I mean, you have the aerodynamic potential of a garbage truck. Have you ever noticed a cement mixer on the back of a vehicle might make a good re-entry vehicle? See also the Vulture Salvage One TV series. But anyway, here we go. Your re-entry vehicle runs on the same idea. You make a very, very symmetrical thing. I mean, it will spin symmetrically, but it's pancaked on the bottom with a warp, and it's got a pin on the back. That's trying to be an aerodynamic teardrop. And it'll start rotating on its axis pretty easily. You don't want it to do that. You're in the spin cycle. So they make it slightly asymmetrical and then be able to shift the weight if they needed to. That was the idea anyway. You can look up how effective that was. Now again, with a bullet. If you don't get a perfect pressed bullet that's made out of pure brass, if it's not pure, it will be asymmetrical. Guess what? All of them have slight density issues. Lead bullets the same way. The heavier it is, the more likely it is, or not, to have a problem like this. See also tungsten impregnated hollow point, armor piercing. They get wonky at a very short distance and start doing this as they go through the air. Now, what if you were trying to spin something end over end, like a bullet? You immediately realize, since it's completely symmetrical in one direction only, the round thing as it goes through the air, it'll probably start spinning on its axis on its own. And it is at the mercy of any Coriolis effect or wind or anything that can cause it to spin one way or another, sort of like water going down a toilet. So when they noticed this wingnut effect and also the tennis racket effect, what they noticed is that even though you can flip a tennis racket from the handle forward, flapjack-like, and get it, if you push it, to where it won't spin on its axis. It wants to because that's the only stable axis to spin at, and you're throwing it through a non-symmetrical spin. If it's not symmetrical, it's going to start spinning in other dimensions. Okay, now here we go with the next one. What if you make a completely asymmetrical object? The symbol for 3 dimensions is a pinpoint in the middle with a array going out up, left, and forward, like that. You know, like a 3-pointed arrow. If you do that, it doesn't want to spin at all because of drag factor in the air. If you try to spin it in one way or another, it will absolutely go chaotic, and it will expend the rotational energy and slow down. Next one, the liquid-filled effect. When you spin a bottle, instead of it spinning along the axis that will allow it to keep spinning the most efficiently and fastest, it will start doing endo or anything other than to spin in the largest dimension. Most objects in orbit around the sun, most objects in space, have a tendency of spinning in a way that the largest dimension is the dominant rotation, just like our galaxy, our solar system, and the Earth at the equator. Now, why am I doing this video? Number one, interesting experiments with firing. Yes, this is the joke. Range scrap fired 38 caliber bullets, fired out of a shotgun as pellets. What ballistics would you have? Would it confuse the crap out of somebody if you wanted to convince somebody that hundreds of people fired one damn shot? Just saying. Next. It's actually useful. It's just not very efficient. In fact, it's very inefficient. Next. Very important about all of this. The reason round balls work the way they do is because they're round, but every dimension's symmetrical. They can also be chaotic. Last. Can you make a bullet fired backwards that's stable with that tail end doing this as a teardrop? The answer is maybe. They tend to keyhole. The stuff that seems completely symmetrical and completely obvious on how you should do things, you have to test it to confirm it works. Everybody who designed bullets found out that a rifle is happier when the pointed end goes out first, which is the lightest end. The heaviest part is in the back. If you do a slug out of a shotgun, it's the other way around. Heavier in the front, lighter in the back, but it's hollow. The aerodynamics take the work off. In a vacuum, both of those will tumble weirdly. Thanks for watching. Have a good day. Good luck with that. Food for thought.